active short. How do we find it? It could be anywhere. So we put 2 or 3 fuses in, and every time we put a fuse in and go to crank the car, it would pop the fuse immediately. Now it doesn't pop it with just key on, but it does pop the fuse when you crank immediately. So we know we have some kind of a short on that circuit. Let's look at the electrical diagram first. Okay, fuse 20 is what's blowing. As you can see, there's 2 pins, 19 and 20. Now 20 is the one that was blowing. 19 should be hot at all times because that comes from the battery. 20 is the side that was blowing, that was showing the ground. So 20 is what we've got to look at. As you go down here, you see we're on circuit F5. It's a red with a yellow, and it goes down here. We've got a splice 100, keeps on going down, and it goes into the PCM, Powertrain Control Module. The power source is blowing to that. We don't have power there, therefore we can't communicate with the computer. But what we want to look at is, why is that fuse blowing? So we want to go back up and look at circuit F5. Now going back here, you see fuse 20 comes down here. We have a splice, S100, and then it also sends power over here to the auto shutdown relay. So fuse 20 can be blowing for any reason. It could be the splice, could be anywhere in here, or it could be anywhere on the auto shutdown relay. So what we want to do is eliminate one by one the branches. Now the most likely branch is going to be the auto shutdown relay. So we know fuse 20 is blowing, and fuse 20 powers up the automatic shutdown relay. So what we did was, with the key off, we took that blown fuse out, put a good fuse in it, and we pulled the auto shutdown relay out of its socket. We turned the key back on and cranked the engine, and the fuse did not blow. So that tells us that the source of the blown fuse is somehow coming through the auto shutdown relay. So now we got to see, what does the auto shutdown relay do? So we left the good fuse in fuse 20. We pulled the shutdown relay out of its socket. Now you know any relay's got a control side and a power side, and we jump across the power side. Now we don't just use a regular jumper, because if we do, we're going to blow the fuse. So we use a circuit breaker. Now what that will do is, every time the short is activated, it'll blow the circuit breaker. It'll take a few seconds for the circuit breaker to cool off, and then it'll energize again. That way we can keep checking, and we don't have to keep replacing the fuses. So what we're going to do is take this auto shutdown relay out and jumper across those 2 pins. So we're going to take the circuit breaker. We're going to hook it up to the live side. You can see that this side is live. So we're going to hook the circuit breaker up to that. You can see that that's live, and that actually goes through the circuit breaker over to the output side, and it's live as well because it's going through the circuit breaker. It tells us the circuit breaker is good. So with our test light is good. We're going to hook that up to the circuit breaker, so that way we'll know when that circuit opens or not. If that circuit breaker breaks and the circuit goes open, we should lose the test light. So I'm going to lay that where you can see it. Then I'm going to take another alligator clip, and I'm going to attach that to the other end of the circuit breaker. And we're going to attach that now to this pin on the relay. Now you see the light went out. That means we got an active short going on. Now that circuit breaker should cool and come back on, and you should see the test light come back on when it's powering on. So we got an active short on this line. Circuit breaker comes on, sees a short, blows the circuit again. This way we don't have to keep replacing the fuse. Okay, so at the auto shutdown relay, we know the output side is where we've got an active short. We come down here, the first thing we run into is a splice 123. So anything spliced off of here could be doing it, or it could be the PCM. But if anything is off of this splice, where most likely the problem is, when it blows that fuse, then we lose power to the PCM as well. So the first thing we need to look at is splice 123. What is on splice 123? So we'll go to our next diagram, and you can see splice S123 is located right here. In other words, this is your radiator, the fender, And right over here is splice 23, somewhere in this wiring bundle. So we need to go there first, and then downstream from 123. Okay, now one thing I want you to tell you. This is a 20 amp fuse that is blowing. It is not a 20 volt fuse. It's a 20 amp fuse. This is a circuit protection device that is engineered to fault whenever more than 20 amps or more pass through it. So what we need to be looking for is amps, not volts. So we're not going to use a voltmeter on this test. We're going to use an amp meter. Now when you buy one of these little circuit breakers, it comes with this amp meter. And now what this is going to read is amps. And it reads it by showing you on the dial. Now we're going to hold this amp meter right up against the wire. The back's just up against it. Now if you watch the meter and the test light, every time the test light comes on, that means the circuit breaker is completing the circuit, and you should be able to read something off the amp meter. So that, look at it real close. The test light comes on, and this amp meter travels this direction. It doesn't go that way, it goes this way. We'll wait and let it do it again. So that is telling us that our current is flowing this way. So we need to go downstream now. We still have the short right here. We need to go downstream. So we're going to go this way. And if you look in here, we're going into the black wire, which is on the output side. Again, going to our splice 123, we need to put this amp meter over there. So what I'm going to do now is I'm just going to take this amp meter and move over here to splice 123 and hold it up against those wires. Now you can still see our test light, so we'll know when the circuit breaker activates. And I'm going to put it down here against this wire bundle. Okay, the meter activated when the light came on. That means we still got a short right there. So we're going to go on further down. Now you can't see it there, but this bundle of wires actually tucks back around behind the water jug over here, and it comes up into this split. We've got a black and a white connector. So what I'm going to do is I got two connectors. I'm going to unplug them both. Okay, we've got them both unplugged. So I'm going to take the white one and plug it in. Now it's plugged in. Let's wait and see if the circuit breaks. So we wait a few minutes. Circuit does not open, so we no longer have a short. Now we're going to plug in the black one. You can see right away, as soon as I plugged it in, our light went out and our meter moved. So we're going to wait just one more time. You can see the test light and the ammeter. We still have our short. So we have our short, and we know that now it continues through this black connector, or this wiring harness right here. Now as you can see, going back to the wiring diagram, that auto shutdown relay going through splice 123 goes down here, and it powers up all of the fuel injectors. Now if you look at this, all the injectors are powered from a dark green with orange wire. Dark green, orange, dark green, orange, dark green, orange. That's because the computer has a different wire to ground them, but they all have power through this dark green, orange. So we actually need to continue now through this circuit and look at our fuel injectors. So now to make sure, we're going to put our amp meter on this side of the wires. And watch our test light to tell when that breaker breaks the circuit again, and watch your amp meter. So now it is still going this direction. The needle went that direction. Now when we follow these wires back, they travel this way, and we looked at that diagram. So we open up this bundle, and we can see right here, right in here we've got a dark green with orange wire. I'm going to put my amp meter right on that wire. Move the test light where we can see it. Put the amp meter right on that wire. Okay, we still got our short. So let's move over to the injectors. Now all of our injectors are right on here. As you can see in there, there's a dark green with an orange wire. So I'm going to put my ammeter right on that wire. So now we watch our test light.
Take a message for him?
If you watch our test light, looking at the ammeter,
Probably where he can maybe be a little more available.
we still have our short. Now, do we have a shorted fuel injector? Well, let's just unplug that fuel injector and see. So the fuel injector is unplugged. We're still going to hold our ammeter up against the fuel injector now. We still have our short, so it is not in the injectors. Now, it's always a possibility it could be one of the injectors, but we did this, we actually unplugged all of the injectors and we still had our short. So let's go back to our diagram. Okay, we're going to go to the next thing. We see the auto shutdown relay goes through splice 123 and it comes down here to the oxygen sensors. If you look at the oxygen sensors, a black, dark green, and orange. So the dark green and orange on the oxygen sensors is on this circuit. So let's find that. Now our fuel injector wire harness actually comes through here and comes out the front. As you can see right here, we still got an orange, dark green with orange. Now we're going to put our meter on here with the wire in the back. And we still have our short. And the needle went this way, so the short is in that direction, or down here from here. Now we actually followed these wires down, and we found a bad spot. So we actually followed this wire down. If you look, you can see this orange with, you can see this dark green and orange wire is actually shorting up against the exhaust manifold. Let's pull that wire up where we can see it better. So we're going to pull this wire up, and sure enough, you can see this dark green with orange wire has got a bad spot on it. It's all discolored, and right there it went through the insulation. It was touching the ground. Now our light's on. It is not going on and off as it was before, because before, every time the circuit would short, the breaker would break and it would open the circuit, but our circuit is still intact because we no longer have a short. Now, just to get a little bit more evidence to make sure it's our problem, actually what I'm going to do is just ground this wire. It's the same thing as if it were touching the exhaust manifold. Now with the power probe, you know, whenever I throw this rocker, if I go forward I send power, if I go backward I send ground up here. So what I'm actually going to do is touch that wire. Nothing happens until I hit the rocker, but I'm going to rock backwards and hit it with ground. And when I do that, you can see the test light dims, and the circuit breaker broke actually in the power probe. So I reset that. So that confirms and shows us that this is our problem. So by reading the diagram, using our tools, we gathered the evidence. We found our problem was on the dark green orange wire. Now if that was not the short, we actually could have continued. You can see that the auto shutdown relay actually goes to the dark green orange again and goes to the ignition coil, dark green orange. So that was another possibility, but we did not need to go that far because we found it on the oxygen sensor. So we used some tools to find this problem. It was an active short, and there's a short circuit finder. Very inexpensive tool. But you know, our most expensive item on here was the knowledge. We got that by looking up the electrical diagram, understanding how the circuit worked, following the electric diagram, using some simple tools, we were able to find the active short circuit.